Look, you just answered.
You notice how the volume went up, or that air blast of air comes out? That's because we have what's called PEEP. And it's saying, I'm trying to maintain PEEP, but there's nothing there. You've got a leak. But it will compensate for leaks. What I want to do is one more adapter. Yeah, you can throw those in there. These two guys here, both of them have been intubated earlier today. Let's see if our- oh, there we go. No, this one's going to be too small. For instance, if your patient has a pneumonia, we're measuring the average, but you'll notice this lung goes up, this lung is not as much. Air will always go the path of least resistance to follow. We're going to come back over here and say diagnostics. Loop.
I know.
So now we'll see what happens. Now we see how much straighter this is coming up. And again, I can pick within it. It's got a belly in the curve at the bottom here. I don't want that part. That is where my alveoli are going to close. Now, this lung does not do the same as a human lung would do, in that it keeps a constant compliance throughout the entire cycle. But if I look at it right in here, my static compliance is 32.9. If I come up, it drops. And so I want it to be above the drop. But if I come down below, compliance is only 18 at this lower portion. So my compliance improves as it went up the curve, and then the center portion of it stays pretty constant all the way through. We want to ventilate our patients in that center portion of it. Patients with ARDS have lungs that look more like this. Notice how steep that curve is going horizontal. The more horizontal it is, the lower your compliance is. It takes a greater pressure to get the same volume change. Again, I would move my cursors and find where I got the best compliance. These two, instead, I've been talking to me here. Okay, let's I can plot any of those, the data. This one is using flow volume. Flow is here, volume is this way. That's how we do our pulmonary function studies. It's a flow volume loop. We're comparing flow versus how much of their volume they exhale. They should get most of it out at the very beginning and gradually slow down. In this case, it's showing me mine is bellowing in on the inside here. It's got more resistance than it should. Now, if I change this person, now you see that belly disappeared. This is a machine cycling. This is the patient exhaling back again. It should be a nice gradual decline coming back up, so I can look at it and say, okay, I gave him a bronchodilator and his airway resistance went down. It changed in the shape of the flow volume curve. When we do pulmonary functions, that's what we're going to be doing. We're measuring each other's peak flows, and peak flows is peak right here at the dot. And then it should be a nice gradual drop down. If not, then I'm showing that the airways are closing as we're trying to exhale. But the graphics we use, the compliance, resistance, and you can see on these ventilators, for instance on this one, peak pressure, plateau pressure, mean pressure, peak. Compliance, resistance, sounds familiar. This one is 8 centimeters of water pressure per liter per second. It gives us both resistance inspiratory and expiratory. We have greater expiratory resistance than inspiratory. And we've got our compliance at 48 milliliters per centimeter water pressure. If I did something changes with my patient, now my curve went more upright and my compliance went to 64. So I can look at the graph and say, I know it went up. I look at the numbers and it tells me how much it went up. Now the one thing is, on this particular ventilator, it's not going to give me a static compliance, it gives me a dynamic. To get my static, I need to have a plateau. So it has here And the plateau is, you see it come up to the peak on the pressure here. It holds for just a second and then drops down again. But it needs a solid one, it needs it over a period of time to calculate. So if I'm looking at it, I just look and say, okay, my plateau pressure is 12, my peak is 5, and my tidal volume is 500. So 12 minus 5 is 7. Divide that into 500, and I know what my plateau, my static compliance is. It will only calculate it over a long trend. Some of them will do one breath. The Draeger does it on a single breath. It does a breath hold and then releases, and it only does it when you ask it to do it.
I got a question. Say if we want to find out their static compliance, does the monitors do that math for us, or do we normally do it like when we're in the field? Are we doing that?
Many times you're doing it in the field. Like in this case, as I said, it will not give me a compliant